Okay, so for today's class, we were supposed to go through indices. Alright, the word indices or the singular form is index. The singular form of indices is index. And it's just another term for power or exponent. Okay, so whenever you hear the word index or indices, you're just talking about powers or exponents. Okay, so what is a power exponent or index? It tells you, so the index tells you how many times you are to multiply a number by itself. Okay, so say for example, the index in 2 squared. Alright, let me use another index. Let me use 3 instead. Okay, the index in 2 cubed is 3. Now the bigger number, or the number that you're multiplying by itself or times itself, is called the base. So the 2 in 2 cubed is called the base. Alright, so now that we know the special terms, let's talk about how do we write a number that is in index form, what we call index form, to expanded form. Okay, expanded form looks like this. So the expanded form of 2 cubed, and by the way, cubed is a special term for the power of 3, and the squared is the special term for the power of 2. Okay, so 2 to the power of 3 is 2 cubed. Okay, so the expanded form for this would be 2 multiplied by itself or times itself 3 times. Okay, so this is 2 cubed in expanded form. Alright, so this is the index form. 2 cubed, and the index form is just the form of the number that uses an index or power. Okay, this can also be used for variables as well. So indices can be used to represent a variable that is being multiplied by itself whatever number of times. So say for example, if I wanted to write, say, a times a times a times a, let us say a is being multiplied by itself 4 times. The index form for that would be, so write in index form a. Now a is being multiplied by itself 4 times, so that would end up being a to the power of 4. And that's basically it for index form. Okay, so once you understand index form, you're going to have to simplify algebraic expressions. Now, when you're talking about algebraic expressions, so simplifying algebraic expressions using the law of indices. Okay, for today's class, we were only going to go through the first law. And the first law says that when numbers with the same base are being multiplied, then all you have to do is add the powers. That's basically it. Okay, so say for example I am multiplying a squared times a cube. Now what we're going to do, we're going to write the same base, and let me put that in the notes as well. Keep the same base. Okay, so remember the base is the bigger number, or the number that is being multiplied by itself. In this case, we're given in index form, but we already know the expanded form for a squared and a cube. But we can use the laws of indices to help us simplify algebraic expressions that have indices. Okay, so what we're going to do, we are going to keep the same base, which is a, and we just add the powers. So we would end up with a power of 2 plus 3 and our final answer is just going to be our final answer is just going to be a to the 5th power. And that's basically it. Alright, so let us write it out in expanded form and see if we actually have the correct answer. Now, a squared in expanded form, remember the power tells you how many times the number is being multiplied by itself. So this in expanded form would be a times a. Alright, so this in expanded form is a times a. And a cubed in expanded form would be a multiplied by itself 3 times, a times a times a. Okay, and remember we're multiplying this, so all of this would be a squared. We're multiplying a squared times a cube. So I'm just writing them in expanded form to prove that the first law of indices actually works. Okay, so we're multiplying these two. So I'm going to write a multiplication sign between them. Alright, so remember when we have repeated, when you're multiplying a number by itself, whatever number of times, you can write it in index form. So we're going to write our final answer from expanded form to index form now. So a is being multiplied by itself 5 times here. So it would be a times a times a times a times a. And that in index form would be a to the 5th power. So we know that this law actually works. Now, when you're talking about numbers and using the law of indices, the law of indices can work for both numbers and variables. So say for example I'm given 2 to the 5th power times 2 times 2 to the 4th power. Alright, so what we're going to do, we're going to keep the same base and we're just going to add the powers. So we have two numbers being multiplied, they have the same base, we're just going to simply add their powers. And that would give us a final answer of 5 plus 4, that would give us 9. Or 2 to the 9th power. Okay, so that is our final answer. Now, there are some common misconceptions when you're simplifying whether algebraic or numerical expressions using the law of indices. So this would be a numerical expression, meaning only numbers, no variables. And this one, the first example, is an example of an algebraic expression since it has variables. Okay, whether it's algebraic expressions or numerical expressions, there are some common misconceptions that you have to keep in mind and ensure that you don't make the same mistake. Okay, sometimes when you're asked to write a number in index form, you may mistakenly multiply the base by the index. Okay, so this now would not be correct. 2 times 5 is 10 and 2 times 4 is 8. That would be incorrect. You are going to look to see if they have the same base, and if they do have the same base, you are going to add their powers and keep the same base. Another misconception that is common is adding the powers when the bases are not the same. For example, if we have 3 to the third power, or let me put it to the fourth power, times 6 to the fifth power. You won't be able to use the law of indices to simplify this expression. There is no way for us to keep the same base because the bases are not the same in the first place. And you would not add the powers either. So this would be incorrect. 3 times 6 is 18. And 4 plus 5 gives you 9. And if you were to check it in your calculator, if you find 3 to the fourth power and you multiply that by whatever number you get when you raise 6 to the fifth power, you would not get 18 to the ninth power. So that is a common misconception. So I'm going to write it at the bottom here. Okay, so 1, do not multiply rather the base times its power. Multiply the base times the power. And do not add the powers if the bases are not the same. Okay, so just keep that in mind when you're using the first law of indices.